All right, this is the second part of 6.7 where we talk about inverse notation. The biggest thing that you need to know here about inverse notation is how to recognize it, how to write it, and how to read it. So the inverse of a function is denoted by f and it's raised to the -1. But you read that as the inverse of f or f inverse, okay? So if you ever see f raised to the -1, that's how you know it's the inverse. Specifically, I would like to see you write it as f of -1 of x. So that way I know your equation is with respect to the x independent variable. So just make a note of that. Like I always say f of -1 parentheses x. So that way I know you're talking about the inverse. So on problem number 4, we're going to go through 4 parts in order to answer this question. It says, consider the function f of x equals x squared plus 4. Now, part A says, what is the domain and range of your function? Well, let's identify this function first. This function is a quadratic, right? So this is a quadratic. What do you know about the domain of a quadratic? Every time it's all real numbers. And the range depends upon your y value. So let's look at our vertex. Our vertex here would be 0, 4. And my a value is positive, so my graph is opening up. So I would say y is greater than or equal to 4. So we have the domain and range of our original function here, done with part A. On part B, it says, what is the inverse equation? So I'm going to change that f of x to a y and say y equals x squared plus 4. So as we just got done talking about, in order to find the inverse, you switch the x and the y and you solve for y. So I'm going to do that and I'm going to solve for y. So I subtract the 4. So I have y squared is equal to x minus 4. And from here, I would take the square root of both sides. And when I do that, I get plus or minus y equals plus or minus the square root of x minus 4. Again, I don't want to use that y, though. I want to use my function notation, f to the -1 of x. So I know I'm talking about the inverse is equal to plus or minus the square root of x minus 4. This is my inverse equation here. So before I answer part C, I want to jump down to part D. Is this a function? And explain. At the end of part 1, we just got done talking about y plus or minus the square root is not a function because you have not passed the vertical line test. Let me go back and show you. If you have plus or minus a radical, okay, so let me highlight here. This would be the positive piece of the radical of the square root, because remember you've already done 6.8, so you know how to graph. That's the positive piece. This would be the negative piece. So essentially you have 2 pieces to that graph, and when you do the vertical line test, it does not work. So anytime you have plus or minus a radical, that is not going to be a function. Now let me go back to part C. What is the domain and what is the range of your inverse equation? Well, all you have to do, you don't even have to look at the function. Remember how we said the inverse is you just switch the x and y's? What you're going to do here is switch the domain and the range. So you would say x is greater than or equal to 4, and your range is now all real numbers. So once you have the domain and range of the original, all you have to do is switch it for the inverse. Not too terrible. Lots of parts, as it tends to be, but nothing too crazy. All right. Y'all go ahead and try this one on your own. If you want to stick with me, though, go ahead and hang right here. You notice that this equation is linear. It's just not in the form that we're used to seeing. We normally see it as y equals mx plus b, so if you want to rewrite that as -4x plus 6, you can. So what's the domain and range? Well, that's a linear function, so we know the domain and range is all real numbers for both. To find the inverse, we're going to switch the x and the y. So I'm going to say x is equal to -4y plus 6. And I'm going to solve. So subtract the 6. So we get x minus 6 is equal to negative 4y. We're going to divide everything by negative 4. And again, we're going to write this like we typically see a linear equation. We're going to say y equals negative 1/4 x, right? Because there's a 1 right there if you need it, plus, because a negative divided by negative is a positive, and that would reduce to 3/2. So let's write it with our function notation. Here is my inverse equation. We can skip down to g again. Or it's not f of x. It's g. There we go. Is this a function? Yes, because it is a linear equation. So that is a function. And what's the domain and range of your inverse? Well, you switch the original, right? And they are also the same. All right. Last thing for today is talking about an application, okay? If you're finding that you have a like a real-world formula, such as the area of a circle, pi r squared, you would not find the inverse by switching the variables, okay? That presents a false equation. And so if you want to find the inverse, you don't go swapping variables here. All you have to do is leave the variables in place and then just isolate the other variable. Okay? So no swapping of the variables when it comes to application problems. All you have to do is isolate. So on problem number 5, it says the function d equals 4.9t squared. This represents the pull, the object that falls due to the pull of Earth's gravity. So it says find the inverse of this function. Okay, again, you're not going to go switching the d and the t. Okay, all you're going to do is isolate the t. Okay, so the first thing we're going to do is divide both sides by the 4.9. And then we take the square root of both sides. So when you take the square root, normally you would have plus or minus, correct? But since time, that's what our t value represented here, time cannot be negative, so we only take the positive. All right? So again, no switching of the variables here, just isolating of the other variable. So if you want to find the inverse, all you got to do is solve for the variable that's not by itself. Okay? So here's our inverse equation. So now the second part of the question says, how long does it take for the cliff diver shown to reach the water below? So this is why we had to find the inverse, because it asked us to solve for t. How long does it take? That's asking for you to figure out what t is. And it says here that the dive is 24 meters, so all I have to do is plug in 24 for d. So I take the square root of 24 over 4.9, and I get 2.2. So it would take about 2.2 seconds for him to hit the water. Again, no switching, just isolating. Okay? So let's try this one on our own, and this will be the end of 6.7. It says the function d equals v squared over 19.6 relates the distance in meters that an object falls due to Earth's gravity again, but it's talking about the velocity. So it says find the inverse of the function. Okay, so we're going to solve for v. So d is equal to v squared over 19.6. So what I'm going to do is multiply both sides by 19.6. So that will cancel out. So I have 19.6d is equal to v squared. So I'm going to take the square root of both sides. So I get v is equal to the square root of 19.6d. Again, though, I wouldn't have plus or minus here because velocity is not going to be negative. So keep that in mind. So that's why I don't have the plus or minus. So this is my inverse equation. And now it wants me to find what's the velocity of that cliff diver as he enters the water. So our distance is the same as the last problem, 24. So we're going to say v is equal to the square root of 19.6 times 24. So let's figure out with our calculator here. The square root of 19.6 times 24 is equal to 21.69, and what is that, meters per second. All right. And there we go for application. If you have any questions over 6-7, please reach out to us and let us know how we can best serve you.